Hey everyone, and welcome to today's Explainer. Today, we're doing something really exciting. We are going to completely demystify the process of building a modern, full-stack, AI-powered mobile app right from scratch. If you've ever wanted to mash up mobile development with cutting-edge artificial intelligence, well, you are absolutely in the right place. Today, we're decoding the blueprint for your very own AI study assistant. Let's get into it. So here is our roadmap for the build. We've got 5 sections. Section 1, the ultimate study assistant. Section 2, the tech stack blueprint. Section 3, step-by-step construction guide. Section 4, code and connectivity. And finally, Section 5, evolving through 4 versions. Kicking things off with Section 1, the ultimate study assistant. Solving the universal struggle of studying. Okay, so this app is going to completely transform how students study. Think of it as a personal, around-the-clock tutor sitting right in your pocket. We are talking about building an application that can literally summarize dense PDF notes in seconds, dynamically generate quizzes to test your knowledge, and even explain complex programming code. Plus, it can translate content and map out structured study plans for you. You're essentially building a pocket-sized super tutor here. How cool is that?
Right. Moving on to Section 2, the tech stack blueprint. Laying the foundation.
To actually build this thing, we need some serious construction materials, and we're using a highly modern, robust tech stack. For the user interface, the front end, we're going to use Flutter. This is amazing because it lets us build beautiful apps for both iOS and Android simultaneously from just one single codebase. For the backend brain, we're running Python, specifically the lightning-fast FastAPI framework, because honestly, Python just handles AI and complex math effortlessly. For the actual artificial intelligence, we'll integrate the OpenAI or Google Gemini API. And for the rest of the plumbing, we'll store user data securely with Firebase or Postgres, manage logins via Firebase Auth, and deploy our backend to the cloud using Render or Vercel, all before shipping the actual app to the Google Play Store. Now, looking at how all this connects in the system architecture, you have this really clean client-server relationship. The student interacts directly with the Flutter app on their phone. But here's the thing. The phone itself isn't doing the heavy AI computations, no way. Instead, it sends a request over a REST API, which is basically a secure digital bridge straight to your Python backend. That FastAPI server acts as the middleman. It securely talks to the AI model, fetches any needed data from your database, and then shoots the final answer right back to the student screen. Okay, let's look at how we actually put this together in Section 3 step-by-step construction guide. From zero to hero. Your journey starts with 4 highly achievable steps. Step 1 is pure setup. Just getting your software installed, things like VS Code, Git, and the Flutter SDK. Then, Step 2 is mastering basic Python. Step 3 introduces FastAPI so you can build out your web server. And finally, Step 4, this is where the real magic happens, writing the code to actually call an AI API. And hey, don't let the Python part intimidate you. The crucial takeaway here is that you really only need about 2 days to master the specific Python fundamentals for this project. You don't need to be a Python wizard. You just need a solid grasp of variables, loops, functions, and classes. Tack on some basic file handling and an understanding of APIs and JSON data, and you've got the exact toolkit you need to build the engine of this assistant. Once your back-end foundation is rock solid, you'll frame the front-end facade by building out some essential UI screens in Flutter. It's kind of like framing a house. You've got a splash screen to welcome the user, which drops them into a secure login screen. From there, they hit the home dashboard, where they can jump right into the primary chat interface to start studying, or they can pull up a history screen to review past notes. Wrap the whole thing up with a settings and an about page, and boom, you've just given your powerful AI backend a highly accessible, super user-friendly face. This brings us to my favorite part, Section 4, Code and Connectivity. Wiring the electricity. Look at how elegant this is. In just a handful of lines of Python, you can spin up a FastAPI server that's ready to receive requests. You literally just import FastAPI, initialize your app variable, and then use a routing decorator, @app.get/, to tell the server what to do when a user visits the main address. That triggers a simple home function, returning a JSON message, "Hello AI." If you run this in your terminal, you will literally see your backend talking back to you. It's awesome. Now, what's really fascinating is how easily we can inject the brain into our apps securely using the OpenAI API. You just initialize a client with your unique API key, then to generate a response, you specify the model, like GPT-5 in this blueprint, and provide an input prompt. Say, explain artificial intelligence. The API processes all of that in the cloud, and you simply print the output text. That tiny block of code right there, that is the absolute core of your app's intelligence. So, how do they talk to each other? Behind the scenes, your mobile app and the backend communicate using JSON. It's a lightweight, standardized text format. Think of JSON as a universal language that both your app and the server speak fluently. Flutter packages the student's question into a JSON object, say a question asking to explain a CNN, and fires it over to FastAPI. FastAPI processes it through the AI, grabs the result, and packages the answer back into JSON format to send down to the phone. The student just sees a seamless chat interface, but this lightweight, continuous data exchange is what makes the whole thing tick. Naturally, as you wire all this together, keeping your code organized is absolutely vital. Your final project directory needs to be cleanly separated. You'll have a backend folder holding your main server logic, routing, AI API calls, and database management. Then, your front-end Flutter folder organizes the UI into screens, reusable widgets, and API services. This strict separation of concerns means that as your app scales up, your code remains clean, readable, and, trust me on this, incredibly easy to debug. All right, let's look at the long-term vision in Section 5, evolving through 4 versions, scaling the AI. Development is always best done in iterations, right? Version 1 is just about getting the core mechanics working. Basic AI chat, saving your chat history, and, throwing in dark mode for those late-night cram sessions. Once that's totally stable, version 2 tackles the heavy lifting. This is where you program the logic to parse uploaded PDF documents, generate automatic note summaries, and dynamically create quizzes based directly on the student's syllabus. That is a massive value add for any learner. But we're not stopping there. By versions 3 and 4, you are transforming this app into a full-blown multimedia powerhouse. Version 3 introduces voice input, text-to-speech, and optical character recognition, or OCR. That means a student can literally snap a photo of a textbook page and the app instantly understands it. Version 4 scales this up to video. You integrate tools that can parse a YouTube link, summarize the video, generate visual mind maps, and create flashcards. Your weekend project is suddenly rivaling top-tier commercial educational software. And here's the best part. By completing this roadmap, you aren't just building a cool app. You're acquiring a massive career-ready portfolio of full-stack development skills. You're mastering back-end logic with Python and FastAPI, front-end UI with Flutter, cloud databases with Firebase, and the incredibly highly sought-after skill of prompt engineering. This single project literally touches nearly every critical corner of modern software development. So, you have the blueprint, you have the code, the foundation is laid out right in front of you. Because this roadmap is completely modular, you can start small with those basic API calls and scale it into an absolute powerhouse over time. So, what will you build first? Are you going to start with the basic chat functionality, or are you eager to jump straight into cracking those PDF summaries? Gather your tools, open up that code editor, and let's get building. Thanks so much for joining me on this explainer, and I'll catch you in the next one.